Hey everyone, today we're going to be looking at a geometric sequence, and we're told that if these three terms are three consecutive terms in a geometric sequence, we want to find the value of k that would make them so. Okay, so first off, since they are consecutive terms in a geometric sequence, we know that all three of them are related. They're related by the common ratio r, right? And they're related in a way that we can get two different equations for our common ratio, because we know that r can be found by taking the ratio of t2 to t1, and likewise the ratio of t3 to t2, right? Also the ratio of any term along the way divided by the term before. So since r is t2 divided by t1, we can assume that this acts like t1, this t2, and this t3. We can set up this equation first as r is equal to 3k divided by k, right? t2 divided by t1. Separately, we can get a second equation for r as t3 divided by t2, and so that looks like 20 minus k over 3k. And then what we have here are two distinct equations for the exact same unknown, namely our common ratio, r. Now, clearly, we're referring to the same r in both of these instances. And so this r is the same as that r. And so they're equal to one another, right? Formally, we say that r is equal to r, and that means that this must be equal to that, right? And so that allows us to make an equation with 3k over k being equal to 20 minus k over 3k. Now, I'm guessing that you're tempted to cancel out these k's. Since k is an unknown, we don't want to cancel it out, okay? We want to work with it. And so what we're going to do here, we have a fraction equal to a fraction. The easiest way to deal with this is to cross multiply. And so we multiply 3k by the expression across from it. And so that means we're going to do 3k times 3k. And that will be equal to 20 minus k, in brackets, of course, times the expression across from it, cross multiply, times k, okay? And if we go ahead and do that, 3k times 3k on the left-hand side is 9k squared. And on the other side, we're gonna have 20 times k, 20k, minus k times k is k squared, right? And so now we have something like a quadratic to solve. Let's bring it up here so we have it confirmed. So we have 9k squared is equal to 20k minus k squared, right? So let's get everything on one side. Let's add a k squared to both sides and subtract 20k from both sides as well. And so that there's nothing left on the right-hand side, and so we have it equal to 0, which is what we often do in solving quadratic equations. And on the left-hand side, 9k squared plus another k squared is 10k squared. And we have the minus 20k as well. And so 10k squared minus 20k must be equal to 0. We can factor this. We can factor 10k out of both terms, and we get 10k times k minus 2 is equal to 0. And so that means that 10 times k minus 2 is equal to 0. We know that if stuff being multiplied together have a product of 0, that can only happen if this k is equal to 0, or if k minus 2 is equal to 0. One of the individual parts of this product has to be 0 for the product of the entire thing to be 0, right? And so either k is equal to 0, or k minus 2 is equal to 0, which would mean that k is equal to 2. And so we have two different options for our value of k. And so we could look at these two cases separately. First off, if k is equal to 0, then our sequence is going to be 0, 0, and 20 minus 0, which would be 20. This is a great chance to address an issue that popped up. This 0 3 times 0, which is still 0, and then 20 minus 0, which is 20. This is clearly not a geometric sequence, right? And so you might think that something's gone wrong. Well, here's what went wrong. Earlier on, when we set up our equation, when we cross multiplied, we had a k in the denominator, right? K being 0 means that in this step, before we work through it algebraically, in this step here, if k was actually equal to 0, we would be dividing by 0. That's a big no-no. We absolutely cannot do that. And so later on, you'll learn about non-permissible values. Non-permissible values oftentimes come up when we divide by 0. And so we could have noted earlier on that k will not be able to be equal to 0. That would be considered a non-permissible value, a non-permitted value. And so that means that we can now address that issue and cross out the solution provided by k is equal to 0, because it violates a condition in our original equation, namely divided by 0. Okay. The other option for a solution for k is equal to 2, that one I believe would give us a good solution. If k is equal to 2 and we plug that into our geometric sequence, our sequence is going to look like 2, then 3 times 2, and finally 20 minus 2, and that means 2, 6, and finally 18. That is a nice geometric sequence with an r value of 3. And that qualifies as a solution. And so, there we go. This was a nice chance to address non-permissible values. Again, non-permissible values often come up when we take the square root of negative values or when we divide by 0, both things that we cannot do. And so, if one of our solution qualifies as a non-permissible value, we can't use it as an actual solution. And so we're only left with one, namely when k is equal to 2. Okay. I hope this helps. If you guys have any other questions or problems that you'd like to see solved in this sequences and series chapter, please leave a comment below, and thanks for watching.